Alright, the histogram provides the distribution of tornado damage in dollars. The most appropriate measure of center and spread are the, you should look at this and say it is skewed data. Skewed data, the best measure of center is the median. And the best measure of spread is the IQR. So the answer is D. Okay. Mean and standard deviation are the best if it is normal. Now these are not the exact questions in the midterm. So it's going to be a question maybe similar though. So maybe it's asked the question on the midterm I asked about a graph that is normal. And then the answer would be mean and standard deviation. Okay. These are not exact questions. They're questions similar. They require the same kind of knowledge. A researcher asked a group of students to provide the political party. The graph that would best represent this data. You should look at this and say, hey, this is categorical data. Pie chart. The best way to represent categorical data is through a pie chart. Pie charts just represent percents of totals. Number 3, which of the following data is quantitative? Classes, group, whether the student has taken the ACT, that's a yes or no, that's group ownership. Whether the student is right or left-handed, that's a group. GPA is a measure of quantitative data. It's a numerical data set. A 4.0 is better than a 3.9, so it holds a place value. That's the definition of quantitative data. Numerical data that holds a place value. The independent variable is weight. Independent is always your X. The dependent is your Y. So once again, it may ask a similar question involving this topic. Alright, so the independent variable is X, the dependent variable is Y. The relationship between weight and miles per gallon is best described as it's got a negative slope, so it's negative. Those points are pretty close to that line, so it is strong and negative. Guys, there is going to be a question on the test that asks you to interpret the strength of the correlation based on the R value. So you're going to need to know those ranges that we talked about. We drew a picture where we said R goes from -1 to 1. If it falls between 0 and 0.2, it was considered weak. 0.2 to 0.5 was moderately weak.
Wait, we need to know that?
0.5 to 0.8 is moderately strong. 0.8 to 1 is strong. Okay? Make sure you know that. I'm not putting that up here, but it's in your notes about R, how to interpret R. The best approximation of miles per gallon of a car that weighs 2,400 pounds is, we find 2,400. It's asking you for the approximation. The line is the approximation, not the data point. The data point is what actually happened. So looking at the line, we get the answer is 39. The students in a biology class kept record of the height of plants for a class experiment. Make a box plot. Are there outliers?
No.
Okay. So you should have made a box plot. The best way to make a box plot would be to just use the calculator, edit a list. I'm going to go through here and type in all this data real quick. 49, 67, 38, 55, 62. You guys get the point? Making sure I don't type it in incorrect. Because if you type it in incorrect, it will give you false answers. Alright, you typed it in the calculator. You go second, quit, back to the main screen, stat, calculate one variable stats. I typed it in as list 1, so second L1. It's going to give me the one variable statistics for that data. I'm going to scroll down. It gives us the 5-number summary. So I'm going to write it down. The 5-number summary is 32, 46, 51.5, 57.5, and 75. Now, whether or not for some reason I don't feel like that's correct. But anyways. Well, like I said, make sure you type it in right.
I got the 0.5s as well.
Okay. So, just give me a second. There it is. There's one mistake. Let's see what. Keep a tally. That's the only bad thing about depending on the calculator. Type it in wrong. There we go. All right, so let's redo this. Stats, calculate one variable stats, L1, and we get something completely different. We get, this is 43.5, and everything else stays the same, right?
50.5.
And the median is 50.5. Okay, there we go. And then everything stays the same from there. Okay, so that's our 5-number summary. Make a box plot for the data. Are there any outliers? The definition of an outlier is 1.5 IQR more than Q3 or 1.5 IQR less than Q1. So the first thing is we need to figure out IQR. That's Q3 take away Q1. 57.5 minus 43.5, which is 14. 1.5 IQR would be 1.5 times 14. And then this plus 21 is equal to 78.5.
Yeah.
And 43.5 minus 21 is 22.5. Are there any points that are beyond that? No. So it's 0 outliers. That means that this box plot, if you were to sketch this, let's do 30, 40, 50, 60, 70, 80. Goes from 32, 43.5, 50.5, 57.5, and then up to 75. And there are no outliers. So the whiskers are connected to the extremes, the max and the min. If there was an outlier, remember the whisker would stop at the last point that's not an outlier, and then all the outliers would appear as dots, right? Number 8. This is a question right off the third exam. A distribution of scores is normally distributed with a mean of 250 and a standard deviation of 75. So they're giving you S of x and they're giving you x bar. The z-score and its interpretation for a raw score of 235, so they're giving you x, is, so it's asking you to find the z-score, so you've got to know the z-score formula, which is your data, take away the average, divided by standard deviation. You get z is negative 0.2. So, well, right off the bat, that tells you the answer is B. Right? It's the only one that has negative 0.2 as part of the answer. But negative means it's, or 0.2 standard deviation is the negative means it's below the mean. So the answer in that case is B. The mean and standard deviation for the normal distribution in the figure below are, this is using the empirical rule. Just knowing how to find the middle of the normal distribution and the size of the standard deviations. The middle is pretty easy. In this case, it's 2. Right? The other way to find the middle is, to find x bar, you take the highest, or I'm sorry, you take the lowest and the highest, add them up, and divide by what? 2. And in that case, you get 2 also. Okay, it's not too hard to draw a line on the middle and figure out the answer. So it's 2. So the answer is either A or B. And then to find the standard deviation, you take the highest, take away the smallest. So that means the total spread of the curve is 20. And the entire curve covers how many standard deviations? 6. And you get 3.33 repeating. No, you don't.
Yeah, you do.
Yeah, you do. You sure? Yeah, you do. Yeah, you do. All right, because it's 2 over 6, not 2 over 3. So the answer is B. 2 and 3 respectively. Respectively means the answers are listed in the same order in which the question was asked. So since it said the mean and standard deviation, then that means they're listed as mean and standard deviation. Scores on a university exam are normally distributed with a mean of 68. The first thing I see is it's talking about the empirical rule. With a mean of 68 and a standard deviation of 9. So this is 77, 86. And that's all I'm going to do because we're only interested in 77. And it says, what percentage of students scored above a 77? I mean, here's how I see it. Here's how I see it. The pink that I have shaded is how much of the curve? 50%. It's half of the curve. It's the bell-shaped curve. The empirical rule says between -1 and 1 is 68. That's divided into two chunks. So this chunk here represents 34%. That means that total, 50 and 34 makes all of this 84%, which is how many people were below a 77. The question asks for how many people scored above a 77. And the entire curve makes 100%. So 100 minus 84 is 16% or above.
What about the percent that scored 77?
You always just treat it as a cutoff score. Above, below, you don't ignore the actual value. Number 11 is a concept question. When we add outliers to data, a few things happen. The shape of the distribution changes. The mean chases the outliers. The median remains a stable measure of center.
True.
That is true.
We
Okay.
gotta look at number 2.
The definition of an outlier, or what we wrote in our notes, the mean always chases the outliers. If you add an outlier, that's when it causes it to be more skewed. And the median, the number that's in the middle, remains stable even if you add a really large or really small number. All right. A lot of people missed number 13 on the exam 3. A lot of people struggle with that.
It's bad.
So,
Wait.
I'm going to go over 12 first, but I'm just saying, moving in, 13 was one that was a common question.
I have a question.
Yes, ma'am.
Did they give different information on question 13? Because I didn't get what was going on there.
I'm going to go over 13 here in just a second. Yeah. Looking at it, it says an incoming freshman took the placement exam in French and math at college ABC. So I know where this problem is going, so I'm going to organize it. We have ABC. She scored a French score of 82 and a math score of 80. At college ABC, the average French score was 72, and the standard deviation at that college was 8. The average math score was 68, and the standard deviation of math at that college was 6. It gives her 2 scores. Okay, she did better than the average in both. Okay, so she's in the top half of the class in both classes. But anyways, we're going to find the z-score for French, which is her score minus the average over 6. You get like 2.67. That's over 8, which makes that not 2.67. That makes that 1.5. Correct?
Yeah.
No, it doesn't.
1.25.
1.25. I'm just testing it. The z-score for math, her score, take away the class average divided by 6 gives her a z-score of 2. All right, so when we think about this in terms of a graph, a z-score, here's 0. A z-score of 1.25 would be here. A z-score of 2 would be here. She's in the higher percentile having a z-score of 2. So she did better in math. Because remember, percentiles, p-values, represent the amount of data below the interested value. Now, a lot of people struggle with number 13. It says, suppose that a student earns a 70 at college ABC French. So we're talking about ABC's French. So here's what we need to say. If they scored a 70 And then it says, what is her comparable score? Well, remember, you can't look at raw data. But if we want to compare two things that are comparable would have equivalent z-scores, because z-scores are standardized. So first off, we need to find out the z-score of scoring a 70 at college ABC. And we're talking about French, right? So we're talking about using this information. The z-score for, we'll call it ABC, is 70 minus 72 over 8. So you get negative 0.25. Now it says, what would be her comparable score, which is X, at college DEF? So we would also have a z-score for DEF, which would be X minus X bar over 8. Where the results of that college's was a mean of 69 and a standard deviation of 10. Now, comparable means their standardized scores would be the same. So the raw score might be different, but the standardized score is the same. So if you got a z-score of negative 0.25 at college ABC, comparably, she would have to have the same z-score at college DEF. So we're going to take that standardized z-score and plug it in.
Because you're comparing.
When you do comparable, the data has to be standardized. Because standardized eliminates all the other variables except for how does that person do compared to the class average. So when you compare, you have to have standardized data. And then it's the same two steps to solve for x. You times by your standard deviation, which is negative 2.5 equals x minus 69. Add 69. And you get 66.5. I think a lot of people put 71.5. That was a common mistake.
I didn't know to use question 12, so I guess
Okay. Make sure you read the instructions, because it said use for questions 1 and 2 on the test.
12 and 13.
Well, it does on 12 and 13 now, but it did say use for questions 1 and 2. If the correlation coefficient is what? R or R squared? R. R squared is called the what? It's the coefficient of determination. It's the coefficient of determination. If R is negative, then the linear regression model also, the slope of the linear regression model is also negative. That is true. R tells you the type of correlation. How close it is to 1 means it's strong or weak. Whether it's positive or negative tells you if it's increasing data or decreasing data. Number 15. This was one that a lot of people missed on exam 2. One would reasonably expect the highway gas mileage to be related to city gas mileage. In fact, a recent study found this to be the linear model. A vehicle that was included had a city MPG of 22 and a highway MPG. Someone can't type. City PMG, highway MGP, and it's supposed to be highway MPG. Anyways, the value of the residual. The residual is error equals observed minus predicted. When we're talking about error, we're talking about the error in the predicted y values. Okay, so error is equal to the y value minus the predicted y value. What's our y values? City or highway? Highway, because it's always y equals a plus bx, or b0 plus b1x. So our y values are a highway. What was the observed highway? 28. And if we want to know the predicted highway, well, we're given a prediction formula. The predicted highway is we just go to the formula 4.62 plus 1.109, and we plug in the observed x, 22. Because remember, what do we put? What's x? X is our city, so we plug 22 in for city. Working that in a calculator, you get that the predicted highway is 29.018. So plugging that into our error formula gives us the error is negative 1.018. Make sure you understand. A lot of people said, or had, what's a residual at the end of the test? Error and residual are the exact same thing. Error and residual are the exact same thing. So the answer for this is B. Uh, 16. The scores on a university examination are normally distributed. Keyword there, normally distributed. With a mean of 62 and a standard deviation of 11. So they're giving you that the mean is 62, the standard deviation is 11. If the bottom 5%, are they giving you a z-value or a p-value or a raw data? They're giving you a p-value. It's a percent, probability, proportion, percentile. Those all start with the letter P. 5%, percentile. Q1 and Q3 are options of percentiles. The probability of something occurring, proportion of the data, those are all p-values. That was, I think, a big struggle on the last test was, when do I use a z, when do I use a p? If the bottom 5% of the students will fail the course. So when we're talking about this, the bottom 5% would be down here. And if we're talking about the bottom 5%, p-values are the area to the left. When we're talking about the bottom 5%, the area to the left is 5% of the entire curve. So the p-value would be what? The p-value would be 0.05. Now, if it would have said the top 5%, that would be up here. But in terms of p-values always tell you the area to the left. So if it said the top 5%, even though we're talking about 5% being up here, the amount of data that's to the left would be 95%. So the corresponding p-value would be 0.95. Does that make sense, everybody? So, it says, what's the lowest mark? So it's asking for a score that a student can still have and be awarded with a passing grade. So we're going to use the z-score formula. But in order to figure out a score, you've got to know the score's z. In order to find the test grade, you need the test grade z-score. In order to know a z-score, we have to have its corresponding p-value, which we do. That's where you go to that chart. I don't have one of those charts on me. You find 0.05. Where at? On the outside or in the middle? P-values are in the middle. So you'd go here and you'd find 0.05. Okay? And you want the bottom 5%, so you pick the one that's just below. So it's negative 1.6, and it's in the fifth column, so negative 1.65. So this p-value has a corresponding z-value of negative 1.65. We have z, we have x bar, we have the standard deviation. The only thing that's missing is the actual data. So we plug it in. Times by 11. It's always the same two steps. 11 times that gives you, I don't know, negative 12 point something. I don't know, negative 12.75 maybe. I don't know. Anybody? Okay, completely not what I said. Negative 18 point what? 18.15. Okay. My accuracy with decimals isn't as high. Negative 18.15 plus 62 gives you that the score would have to be a 43.85.
That's close to 45.
So the answer is 44.
Now what I did, Mr. McKay, I done 62 and minus 11 twice. And that's what I did.
You did it that way. If you minus it twice, it doesn't give you the bottom 5%, it gives you the bottom 2.5%. But that still gives you a close enough answer, right? Yeah. And you could technically just find the z-score for all of these. If you, and it really stumps, you could just find the z-score for all of these, find the p-value for all of them, and figure out which one's closest to being in the bottom 5%. And that would have been 44. Okay, because 62 would have gave you a p-value of 0.5, 50% of the data, because it is the mean. And you can go on so on and so forth. But, if you get stuck and don't know the exact way, that would also work. All right, use the following information for 17 through 19. SAT scores have an average of 1,026 and a standard deviation of 209. There's that word respectively again. It's just listed exactly how it's listed earlier in the sentence. Okay, so assume that a highly selective university requires you to have an SAT score in the top 15%. Here's what we're talking about. 15%. It says the minimum score on the ACT. So it's asking you to find an actual raw score. What would the SAT score have to be? It's asking you to find X, which means we're going to use the Z-score formula. If you look at what we have, it's asking us to find X. It's giving us X bars 1,026. It's giving us the standard deviation is 209. The only other, in order to find X, the only thing else that we need is the Z-score. But in order to find a Z-score, we need its corresponding p-value. To find p-value is the amount of data to the left of the cutoff. So we're talking about the top 15%. Its p-value would be 0.85. Okay? Top 15% has a p-value of 0.85. Because we were talking about the amount of data to the left of the cutoff. And then once you get to that, it's the exact same concept as 16. You find 0.85, it's 1.04, right? 1.04. You go from there, 1.04 times 209, add that to 1,026, you get 1,243.
So when you're looking for the top, you go just above.
Correct. Well, what do you mean? Go ahead and ask that again.
For when you're looking for the top of the P chart, you look just above.
Yes, correct. Because if you're in the top 15%, then 84.9% is just slightly less than the top 15%. 85.1 would be like the first person in the top 15%. Yep. But it's not going to make that big of a difference if you pick, because they're just two apart. You know what I mean? So they're just a 1/100th of a decimal of a Z-score apart. So it's not going to make that big of a difference to get the answer, with it being a multiple choice test. Okay. The first quartile, Q1 for SAT scores. Q1. That deals with box plots. Box plots break your data up into percentiles. Part of your data analysis project was you had to do a percentile analysis. Talk about the lowest 25%, the highest 25%, the percentile that had the most spread. Q1 is what talks about the bottom 25%. So everything to the left of this is 25% of the entire data set, which means its p-value is 0.25. Going from there, I don't know. Anybody have the answer? C. Okay, C sounds good to me. It's identical to the problem before, which is identical to the problem before that. I'm not going to spend any more time going over it. All right, the percentage. Key thing there, guys, it's asking you for the percentage. Percentage starts with the P, we need a Q value. Okay? The score below 950, so it's giving you an X, it's giving you a raw data, raw score. That gives us enough information to find.
Also, like, use the percentage, find the Z-score, and plug it in and see if you get close to 950.
If it's a multiple choice test, yeah. You could technically, if you're not sure how to do this, you could do all of these as p-values and work backward. All right, so it's giving us the enough information for Z. 950, take away 1,026, divided by 209. You get that the Z-score is negative 0.363. Now it's asking for percentile. Now, one thing here is, make sure you pay attention. What is it? 1,026 is here.
That already gets rid of 60.
950 is here. I mean, so that means the answer has to definitely, when it's asking for the number of scores, what? Below. So, do we use the p-value, or do we have to use the p-value of the opposite z-score? We just use the p-value. We need need area to the left. If it needed area above, we would use the opposite z-score. Okay? But anyways, yeah, we know the answer is less than 50%, so we can automatically mark out B and D. And but anyways, we find negative 0.36. Now, we're looking for a p-value. It's giving us a z-score. So in that case, we're going to go to our perimeter numbers. Negative 0.3, and then 6 is roughly 35.8%. Okay? If you find this, the p-value for negative 0.36 is, I think it's 0.3594 or something like that. It's close to 35.8%.
And close to
The major purpose of a box plot is to identify outliers. Okay, now, like I mentioned before in the class, guys, this question is not identical. There's going to be a question that just says the major purpose of a box plot, histogram, pie chart. It could be any of those. Okay, it's the same concept. Major purpose of a pie chart is to organize categorical data. Major purpose of a histogram is to identify the shape of the distribution and the mode. So there's different answers depending upon what the major purpose is asking about. One research reports that correlation between gender and athleticism. Right off the bat, there should be a red flag. Correlation only deals when the variables are quantitative. Gender and athleticism are both categorical data. So the results are meaningless. If you try to do a linear model that represents categorical data, it's not going to give you any accurate results. Remember, use the following information for the last 7 problems in this packet. The interquartile range for sodium is, you need to know the formula for IQR. It's Q3 minus Q1. I've already showed how to do that in the calculator. You would type in the list, sodium list, right? Go to one variable stats. One variable stats will give you Q3 and Q1. You get the answer is 9.